Good morning, guys. Welcome back. Another week, another three assignments. Three. I'm giving you three. That's it. Come on. There's no excuses for you guys not to get this done. But they asked me on Friday to submit what percentage of my students are turning their work in. According to my last quiz, 85% of my students are turning their work in. So I'm really proud of you guys. Honestly, super happy. I get to talk about and brag about you guys in front of all the other teachers who say that they're only getting 60 to 70% completion. So well, I'm really happy. Keep it up, guys. I really appreciate you. I really do. I'm gonna jump right into this. Uh, your test review here. Nothing of this is gonna be turned in. This is all for you guys. You do all of this. I'm gonna do all these problems today and tomorrow, and I'm gonna release a test tomorrow. You guys have till the end of the week to do it. My suggestion, go through this, do this all on your own, best you can. And then go through and watch the video, pause it after each question and check and see if you got the questions right. And if you did, great. If you didn't, that's the time to ask questions. I'm going to be on Google Meets, which is in the Google Classroom. You guys can go there. Let me pull it up here. I can show you guys real quick. If you go to your Google Classroom and the classwork here, and you go to Mr. Johnston's Google Meet, every day there's going to be a link right here, exactly at 9:30. I will have changed that link. If you click on it, it will take you to a Google Meet, and you will see my ugly mug sitting there ready to answer questions, okay? Every single day at 9:30, 9:30 to 10. I got 30 minutes there. Come in and ask me questions. I'm gonna ask you guys, don't come in unless you have questions. It's not a hangout time. It is definitely time to square anything up that you guys have issues with. Okay. Okay. Other than that, I'm gonna get right into this. Let me pull this back over here. All right. Um, Again, you should have this done before viewing it, but I'm gonna jump right in. And we're gonna start here with problem number one. Make a line plot for the set of data. Find the measures of center and variation, then analyze the data. Here we go. We're going to take the set of data. I'm going to make sure it's in order from least to greatest. So I'm going to go 39, 42, 44, 45, 46, 48, 48, 48, 51. The mean, the average would be to add all these up. That would be 8, 46, 48, 348, and 51. It's 10 numbers. 10 numbers, 450, and we're going to divide that by 10, which is 45. So my average, 45 on number one. My median is going to be the middle number, so we're going to count in till we get to that center numbers between 45 and 46. So right in between 45 and 46 is 45.5. That's right in the middle of those. The mode is the number that shows up most often. The number that shows up most often is clearly 48. It shows up 3 times, so the mode is 48. The range is the distance from the smallest number to the largest number. In order to find the range, we do the largest number minus the smallest number. So 51 minus 39. And the distance between those is 12. That's the range of our data. Then to find the interquartile range, we find quartile 1 and quartile 3. So since this is our median right here, then the middle number of the first half is going to be Q1, which is 42. The middle number of the second half is 48. That's Q3. The distance between 42 and 48 is 6. So interquartile range is 6. Now we need to create our line plot. So we're going to take all this data up here. I'm going to put we put x's above each one there is. So example, there's one, or we've got 239. So we will put 2. Are you going to help? What are you doing? She wants to be famous. 42, 44, 45, 46. There are 3 48s. Remember, we try to keep these x's lined up best we can so we can compare this well. And then there's a 51. Then it says to analyze the graph. How many golfers' scores were recorded? Is there a peak? Is there a cluster? Is there a gap? What's the best score, worst score? So on and so forth. There were total of 10 scores recorded. There don't seem to be any clusters. I wouldn't really say there's too many gaps either. Technically, there are gaps, and if you said that these were gaps, you could make an argument for that. But I would say that the data is not too spread apart to where you would really concern yourself too much with it. And then you could say something, say like the most common score was 48. The lowest was 39. And the highest was 51. That's it. It's a great way to answer those questions, and you just got to give me some information about the graph. Not too much more. You gotta wait, girl. For exercises 2 through 8, we're gonna look at the histogram over here to the right. It's gonna ask us some questions about it. Number 2 here, which interval represents the least number of flowers? So the number of flowers goes up the side here. So however high the bar is, that's how many flowers we're talking about. So the smallest is this one over here, right? It only goes up to, it looks like in the middle of 2 and 4, so 3. So there's only 3 flowers that are between the heights of 37 and 48 inches. So that interval represents the least number of flowers. 37 to 48 inches. Which interval has 5 flowers? Well, if we travel up along here and find out where 5 flowers is, that's this line right here. And we look across, and there's only one interval that has 5 flowers, and that is the interval of 1 to 12 inches. Get my keyboard out of the way here. Number 4, how many flowers are 24 inches or shorter? 24 inches or shorter. We have our interval right here is 25 to 36. So these flowers here are all 24 inches or shorter, but so are these ones down here. Okay, we had a couple problems last week where some kids thought that 24 inches or less just meant this. No, it's everything below. So it's going to be all of these and over. So there are 11 flowers in this interval here, plus 5 flowers in this interval down here, for a total of 16 flowers that are 24 inches or shorter. 16 flowers. Number 5. How many flowers are at least 37 inches tall? Well, these aren't at least 37 inches tall. These are not. They only go up to 24. And these only go up to 36. So the only ones that are at least 37 inches tall are the ones up here. There's only 3 of them in that interval. Number 6. How tall is the tallest flower in the survey? Good question. That's a question we cannot answer. The only thing we know is that there are 3 flowers between 37 and 48 inches tall. Unfortunately, with the histogram, it does not tell us exactly how tall those flowers are. It only tells us the interval in which they're in. So, the answer to this question, we don't know. Histograms show interval ranges, not exact data. How many flower heights were used in this survey? Now, that's a question we can answer. Okay, we can see exactly how many flowers were in the survey because there's 5 flowers in this interval, 11 in this interval, 8 in this interval, and 3 in this interval. For a total of 16 and 8, 24 and 3 is 27. What is the most common height of flowers? The exact height, again, we don't know. Um, but we do know that the most common interval of height of flowers is going to be this biggest one right here that has 11 flowers, and that is the 13 to 24 inch interval. And that's going to take care of page number 1. Over here on the next page, I'm going to finish this one up and get out of here, and then tomorrow we'll do the other pages. Again, I'm going to try to work through these kind of quickly, but you guys can pause this video at any time you want to, okay? And again, if you've got questions, make sure you ask me in my live feed if I don't explain something well enough, okay? All right, here we go. Price in dollars of bicycles. And we got to put this in order from least to greatest. So it looks like 125, 120, and then 125, 120, 125, 130, 134, 136, 140, 145, 145, 150, 170, and 190. Now we're going to take this and we're going to we're going to find the minimum value, 120, that's the smallest. The maximum value, 190, that's the biggest. Now it wants us to find the median, first and third quartiles. In order to find the quartiles, you got to find the median first. So we're going to find the middle number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 numbers. Nice. That means there's going to be one number in the middle. So we count inward to find that exact middle number. And there it is. 140 is our median. And then the first quartile is going to be in the first set of 5 numbers here. 1, 2, 3, 4, 5 numbers here. The middle one there is 130. So that's going to be Q1. And then we look at the second half of numbers here from our median, remember. The second half of numbers here, between 145 and 190, there's going to be 150. So we're going to go third quartile, 150. And we have to create a box plot here over this information. So all you need is these 5 numbers, if you remember. So we're going to put these 5 dots. I'm going to create that box and whisker plot down here. So the minimum number, 120, so we'll put a dot right there. The maximum, 190, we'll put a dot right there. The median was 140, dot there. And our first quartile, 130. And our third quartile, 150. And this is how it looks. The middle 3 dots all make a box. A line down the middle. And then you draw lines out to the minimum and maximum. Just like that. Okay. Moving on. 10, what percent of U.S. vice presidents were at least 60 years old when they took office? So we can take a look at and I believe this might have been a question on one of you guys' forms that we did. It's good, we're going to go over this. What percentage of U.S. vice presidents were at least 60? Well, if we look on our chart here, box plots are always split up into 25%. So a total of 100% of presidents here, 25% of them down here, 25% of them right here, 25% of them right here, and 25% of them right here. The question is, what percent of them were at least 60? Were these presidents down here at least 60 years old? Clearly not. They're between what seems to be 35 and 50, somewhere in that range. Were the presidents in this area right here at least 60 years old? Doesn't look like it. They only go up to about 53. Were the presidents in this section here at least 60 years old? If you look down here, no. Do they get up to 60 years old? Looks like it. But are they at least 60? It doesn't look like it. It looks like all the presidents up here in this part are at least 60 years old. They're 60 and up. So we would say right here, given the data that we have, only 25% of the presidents, or the U.S. vice presidents, were at least 60 years old. Only 25% of them, because that's just this part right here. The rest of it is the rest of the presidents, and they are not at least 60. Number 11, what percent of U.S. vice presidents were between the ages of 49 and 60 when they took office? Well, between 49, it looks like right here is 49, and here is 60, and we would say that there's 25% and there's 25%, so a total of 50% of U.S. vice presidents were between the ages of 49 and 60 when they took office. Next question, what is the interquartile range of this data? Well, you do have to kind of guess here. I'm assuming that this is 49 based on what they just told us. So we'll say that this is 49 and this is 60. So the interquartile range would be the distance between Q1 and Q3, and the distance between 49 and 60 is 11. So we would say 11 is that interquartile range. Okay, we've got some multiple choice questions down here. Let's see if I can make this so a little smaller. Number 13. Which data are represented by this dot plot? This is a good question. It looks like here you have to match up these numbers with these ones over here. My suggestion would be to, I don't know, pick a number and then see if the set of numbers over here has that. So for example, this one has, our dot plot has 3 ones. So every one of these, our answer over here must have 3 ones in it. So if we look at A, it's got 1, 2, 3 ones. That's a good one. If we look at B, it's got 1, 2 ones. B cannot be the answer. Automatically, we know that. B cannot be the answer because it only has 2 ones. C has no ones, so C automatically can't be an answer. There we go. We've got it whittled down to either A or D already. D has 1, 2. D has 3 ones as well. Let's check for zeros. I mean, why don't we do zeros? Yeah, it has to have 2 zeros. So this one has 1, 2 zeros, and this one has 1, 2 zeros. So both of them still in the running here. Looks like this set of numbers up here has more numbers than this one down here. So what we could do at this point is actually count how many numbers are in the set of data, and then we would know which one of these it is. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total numbers. And if we count and see which one of these has 15 numbers, then I think that's going to be our answer. 7, 8, 9, 10, 11, 12, 13. So it doesn't seem like this is going to be the answer, but let's just make sure in case I counted wrong. Let's count this one up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 numbers over here. There's 15 numbers in this one and 13 in this one. This can't be our answer. Our answer to this is A. Next one down, number 14. Box plot shows some student test scores. Select whether each statement is true or false, representing this box plot. Half of the test scores are between 70 and 85. That is true. 25% here, 25% here. That's half of them. The lowest test score is 60. That's false. The lowest test score goes all the way down here to 55. The mean of the test scores is 78. Unfortunately, we can't tell the mean of these test scores because we do not know what they are. So that is false. The median test score is 78. That is something we can tell because the median is the direct middle number here, and it looks to be like that is 78. Let's say that's true. The mode of the test scores is 85. That's another measure of center we can't tell from a box plot. We can't tell what the exact numbers are, so we would have to say that's false. The last one, more than 25% of the test scores are between 55 and 70. Well, between 55 and 70 is 25% of the test scores. So it's not more than, it is exactly 25% of the test scores. So we would say that's false as well. Kind of a tricky question, tricky wording there. All right, the last two questions here we're going to do. Number 15. Guys, come here, bud. Can you chill? Which of the following is a statistical question? Remember, statistical questions are questions that collect data. You're going to get different answers from anyone that you ask, right? So if you come across a question where if you ask everyone and they only give you the same answer, then it's not a statistical question. It's like, what color is the sky? Everyone's going to say blue, except for my jerk students who would say, at night it's black. You know who you are. 15. Do you like oranges? If you asked everyone that question, would you get the exact same answer every time? I don't think you would. I think you would get different answers. That's a statistical question right there because you would get yes or no answers. Um, B, how old is your cat? Well, it depends if that person has a cat. But that's also a statistical question. A statistical question because you could get a lot of different answers there. C, what was today's highest temperature in the city? Now, assuming the person knew that and they were accurate, that would only be one answer. It would only be one answer. That would be the highest temperature of the city that day. That would not be a statistical question. D, how many texts did each student in my school send today? That is a statistical question because each person is going to give a different number there. So technically, in this problem, there are three statistical questions and one that is not. Maybe there's a typo or something. Maybe this is supposed to say which of the following is not a statistical question because there is only one of them that's not a statistical question. That's this one right here. The rest of these are all statistical questions. That's kind of a tricky one. I'll have to figure that out. Number 16. Number 16 says which of the following is not a statistical question. Maybe this got mixed up a little bit. We'll see. A, how many petals does a daisy have? Now, daisies, I believe, typically have a certain number of petals. I'm not quite sure there, but I'm assuming that answer would be the same um, across the board. B, how many boxes of cookies did each member sell? Statistical question. How many brothers does each student in my school have? That's a statistical question because it's different answers each time. And how many points does each player in the league have for the season? Again, a statistical question. We're going to say that the petals on a daisy is not a statistical question. So that's going to be our answer to that one. All right, guys, that's going to take care of the first page. Hopefully, you guys did okay on that. If you got questions on any of those, let me know. But the next one, the next two pages of this, there's only a couple more questions of these. Let's see here. On the statistics review, this one's pretty quick. That's not too bad. And then there's only two more back here to practice mean, median, and mode, and some measures of variation. So, 2 days to practice this up. This is part one. Tomorrow comes part two, along with the test. You have to the end of the week to get it done. See you guys.